Hi everyone. Today we're going to be talking about the 2019 Mississippi River flooding, which is one of the longest and most damaging flood events in the river's recorded history.
In this presentation, we'll explain what caused the flooding, the weather patterns behind it, the geographic areas impacted, and the human, economic, and environmental effects. There were several climate signals that contributed to the 2019 flooding. One major signal was an increase in precipitation, meaning that more rain and snow were falling across the Mississippi River watershed than usual.
Another signal was increased runoff and flood risk. Because so much precipitation fell and the ground was already saturated, more water flowed directly into rivers instead of soaking into the soil.
A third factor was rapid snowpack melt. Warmer temperatures caused snow to melt quickly in the late winter and early spring, which added large amount of water into the river system.
Other contributing signals include changes in the large-scale global circulation patterns and Arctic amplification, which can affect storm tracks and increase the likelihood of prolonged wet weather patterns. The floods in 2019 were largely driven by extremely heavy precipitation combined with rapid snowmelt across the Mississippi River watershed, especially in the upper Mississippi and Missouri River regions.
One key event was a late winter bomb cyclone storm in March 2019, which brought intense rain, warm temperatures, and rapid snowmelt all at once.
Because the ground was still frozen in many areas, the soil couldn't absorb the water. Instead, the water ran directly into rivers, increasing runoff and pushing water levels far above their banks.
In addition, the winter of 2018 to 2019 already had above normal snowpack and saturated soils, which made flooding worse than these storms occurred. The flooding lasted for an unusually long period of time. In some locations, rivers levels stayed above flood stage for months.
For example, in Wisconsin, the river remained above flood stage for more than 40 consecutive days, while in Baton Rouge, Louisiana, it stayed above flood stage for over 200 days, breaking long-standing records.
The Mississippi River Basin is extremely large, draining water from 31 U.S. states and parts of two Canadian provinces.
Because of this huge drainage basin, flooding impacted a large geographic region from northern states like Minnesota and Wisconsin all the way down to Louisiana. One key point is that flooding was seasonal and storm-driven. It began with winter snowpack and early spring storms.
Heavy rainfall continued throughout the spring and summer, meaning the flooding wasn't caused by just one storm, but by repeated rainfall events over a very large areas.
Another important factor was the combination of precipitation and snowmelt, which significantly increased river discharge.
In fact, the 12 months leading up to April 2019 were the most wet on record in the continental United States, which added enormous volumes of water to rivers before the flooding event began. Flooding along the Mississippi River is not unusual, but the 2019 flood was exceptional because of how long it lasted and how much water was involved.
Climate change may also play a role. Warmer global temperatures allow the atmosphere to hold more moisture, which can lead to more frequent and intense rainfall events.
Another factor is human modification of the river. Over time, the Mississippi River has been one heavily engineered with levees, dams, and channel changes.
Some research suggests that these modifications can actually increase the magnitude of extreme floods because they change how water flows through the river systems. The flooding has significant impacts across a wide region. At least 12 people have lost their lives, and around 14 million people across 19 states were affected.
The flooding was worsened by record-breaking rain and snow, which created saturated soils that could no longer absorb additional water.
Overall, the disaster caused about $20 billion in economic damages, making it one of the most costly flood events in recent history.
The floods had major impacts on agriculture. Over 19 million acres of farmland were left unplanted, which caused large economic losses for farmers.
Floodwaters also carried fertilizers, pesticides, and septic waste into the river system, which created water contamination issues.
These disruptions also affected the national food supply chain, especially in the Ohio and Missouri River valleys.
To try to manage the flooding, many communities relied on the Mississippi River and Tributary Project, which include levees, reservoirs, and floodways designed to control water flow.
Emergency responses also included sandbags and temporary flood barriers used by local communities to try to protect homes and infrastructure.
However, many of these barriers were not designed to handle such long periods of extreme water pressure, so some of them failed.
Because of this, some agencies have started considering managed retreat, which means relocating communities out of high-risk flood areas, restoring those to natural floodplains. Following the flooding, several policy changes were proposed or implemented to reduce future risk.
For example, Missouri ended tax subsidies for developers building in floodplains, where Illinois strengthened protections through the Wetlands Protection Act.
There has also been a shift toward green infrastructure, such as restoring wetlands and reconnecting floodplains to rivers.
These natural solutions can act like sponges that absorb floodwater, and they are often more cost effective than continually repairing aging leaf systems. Overall, the 2019 Mississippi River flood shows how extreme weather, climate patterns, and human land use can combine to create major disasters.
Understanding these causes is important so that communities can better prepare, adapt, and reduce flood risk in the future. Thank you for listening.